for invite me for this talk.
It's great to have you here, Pub.
Okay, so I hope you all will learn something new in this session.
And Pubudu, just one more thing before we get started regarding the quiz. So so at the end of the session, Pubudu will ask maybe one question based off the session he's going to do. So the first person to answer the question, either you can add it in the chat, you can type it in the chat, or you can unmute yourself and answer. The first person to answer the question correctly will win the credits. We will send the credits to you via email after the session. So yeah, that's the rules of how the quiz will work. Just for people who are excited about the credits, I just wanted to give a little brief. But yeah, hope you guys enjoy the session. Pubudu, rest is up to you.
Nice. Cool. So so brief introduction about me. I'm Pubudu Jayawardana. I'm a Sri Lankan, but now living in Amsterdam, Netherlands. And I work as a senior backend developer at Start. And I'm a AWS community builder in serverless category. And I'm 2 times AWS certified. And whenever I have free time, I tend to create stuff using serverless, and I blog about them mainly in these platforms. Talking about this project I created. So this project is basically a POC I created to showcase how a typical webhook management system can be implemented using AWS Serverless. So thinking about the webhooks, still webhooks are a preferred way to communicate between systems, and by nature webhooks are event driven, right? So whenever something happen in our system, we might need to send this data to a third-party system using webhooks. At my workplace, we have a candidate experience feedback system where we deal with a lot of application tracking systems, or ATSs, that we use webhooks, or the ATS used to use webhooks to send us data whenever, for example, there's a candidate created in their system, or candidate is change its stage to hiring, etc., etc. So those communication happen heavily with webhooks. So I decided to create this whole webhook management scenario with serverless. So why serverless? So there are several advantages building such system with serverless. Mainly, as I said, webhooks are event-driven, and serverless has great support for event-driven scenarios. And serverless systems scales really well, and elasticity is inbuilt. For example, it can scale up as well as scale down to 0 even, depending on the load. So you don't want to keep these services up and running, paying for the idle time. The other thing is with, especially with AWS, AWS Serverless has a large variety of services, and integration between those services are really easy. So you only have to focus on your business logic rather than maintaining different systems. This is the architecture of this project that I created. There are 3 main functionalities. One is to register a webhook, and the other one is create a candidate, and then the whole flow works to send out some data to the webhook related to the candidate created. And then there's another feature to see the webhook history. Before dive deep into this architecture, I would like to discuss some of the services I used here. So first one is API Gateway. So API Gateway is a fully managed API service offered by AWS, and there are two main API types, RESTful APIs and WebSocket APIs. And the commonly used RESTful APIs have two variations, REST APIs and HTTP APIs. Names are not so human friendly, I would say, but yeah. So the REST APIs have the advanced features like caching and request response validation, usage plans, API key-based throttling, etc. But if you need a very simple API to be exposed, you can just use HTTP APIs. Good thing about API gateway is that it integrates well with other AWS services, especially for the serverless. We can easily expose an API and send this data to, let's say, a Lambda function quite easily. Since the API gateway is a serverless service, you only pay for what you use, and that applies for both REST and HTTP APIs. And how the pricing works is you pay for the number of requests that process in the API gateway. And but for other features like caching, you have to pay additionally. Next service I used is Lambda, which is very popular service. And Lambda is a function as a service offered by AWS, which means user is responsible for the code and AWS manage the infrastructure, patching, etc. And there are different runtimes available by default, Node.js, Python, and different version of them as well. And even you can create your own runtime using runtime API, which means literally any language can run on top of Lambda. How Lambda works is there are things called triggers that spin up the function, and the code executed, and then it automatically shut down or times out based on your configuration. And these there are a lot of triggers like SQS, SNS, or API gateway, etc. And also Lambda integrates well with the other AWS services. For that, it uses the SDKs. We can use the SDKs within our code to integrate with or communicate to the other AWS services. So there are some native integrations like Lambda destinations. So with all these capabilities, Lambda is I would say like a multi-purpose service because it integrates well with other services. So it's not only for the small microservices, but machine learning tasks, or even you can use a utility to manage your infrastructure as well. Again, this is a pay-per-use model where you only pay for the usage. Price is calculated based on the memory and the execution time of your function. Next feature or service I use is DynamoDB. DynamoDB is a fully managed NoSQL offering, and it guarantees a single-digit millisecond performance at any scale, which is quite impressive. And one of the key features I even used in this project is DynamoDB streams. How DynamoDB stream works is whenever change happen to a DynamoDB data, those data will be available in a data stream. So for example, let's say a record is created in the system or record is updated. Those data will be available in the stream, and we can configure some other services to listen to that stream. For example, the common use case is the Lambda is listening to the DynamoDB streams. So just before last reInvent, I guess, AWS offered release a streaming filtering mechanism. Sorry, I heard some noises. Maybe it's great if you all mute yourself.
I'm a little giggly.
Thank you. So, okay, what I was saying is just before last reInvent, AWS released streaming filtering functionality for Lambda function. Because previously when a Lambda function is configured to listen to a DynamoDB stream, what happens is all the data that's even not necessary for the Lambda function received from the stream. For example, I only need to listen to the insert type of action, but I will get delete or update actions as well. So I had to filter it within the Lambda function. So with this new filtering feature, now within DynamoDB streams, we can configure I just only need the insert, for example, insert action. And also it's great because I can even filter down to the data level so that I can check if there's a particular data available, if only to trigger the Lambda function. In this project, especially I use that feature to trigger this Lambda function based on the stream. Only when insert action happens, and also the type of data is a candidate. Talking about the pricing, it's a bit complex in DynamoDB how the pricing works. There are two elements called read capacity units or RCUs, or write capacity units, WCUs available to calculate the pricing. And there are two pricing models as well. One is provision capacity and the other one is on-demand capacity. How it works is in provision capacity, you have to define upfront how many RCUs or WCUs you need. And it's not really a serverless way, but if you have a predicted performance, yeah, of course, it's a very cost-effective way. On the on-demand capacity model, it varies based on your usage. Next service I used here is EventBridge. EventBridge is a serverless event bus service offered by AWS. And actually, it was previously known as Amazon CloudWatch Events. And then it was rebranded as a new service called EventBridge. I think still the CloudWatch events is event APIs exist, but all the new features are only available in EventBridge. So it's recommended to use EventBridge over CloudWatch event APIs. So all the events comes into EventBridge is associated with the event bus. Event bus can be a default one or a custom one. So you can create custom one. There's a default event bus as well. Event sources are the ones actually add the events to the event bus. There are different event sources. AWS account itself is an event source. So all the things happening within AWS account, for example, S3 events, SQS, SNS, all these events are available as an event source. And those events can be read from the default event bus. It's only available in the default event bus, not for custom ones. But there are third-party event providers, event sources as well, such as Datadog, MongoDB, Freshwork, etc. Those are natively supported by EventBridge. Talking about EventBridge, there are two other components, rules and targets. Within rules, you can basically you can create rules to send data to a particular target based on certain conditions. So you can kind of have a filtering. So rules are basically filters, or you can have rule as a schedule as well. So for a given time, you can trigger that schedule to send some data to targets. Talking about the targets, targets can be a Lambda function, SQS, SNS, etc. And in this project, I use a step function as a target. Again, the pricing model is pay-per-use. So you pay for number of events that are published into the event bus. However, the AWS events are not charged. So any services that produce events that added to the default event bus, those are not charged. Next service I use is step function. This is a kind of main functionality of that system. So step function is a low-code orchestration service. Its main component is state machine. In the state machine, we can define how the different services should be coordinated with each other to build our business logic. For example, you might need to have some tasks to run parallelly or sequentially, or for example, the output of two tasks needs to be aggregated as the input of the another task. So you can all of these can be coordinated or visually arranged using a state machine. State machine uses the language called Amazon machine language, which is really human-friendly language. You can easily learn that. Recently, AWS launched the step function workflow studio, which allows you to drag and drop and create these state machines, which is quite convenient. So you can export those state machine in ASL language or as well as a PNG. This is actually an export of export from the Workforce Studio. There are again the step functions support most of AWS services. So at the moment, using the SDK support, it does support around 200 plus AWS services. Previously, it was very limited number of services, but this SDK support announced last year. So which allows around 9,000 API actions to be integrated with step functions. Talking about the workflows, there are two types of workflows you can create in step functions. One is standard and the other one is express. The main difference is standard has can run a duration of 1 year. So that's the main advantage. And for the express workflows, it's just 5 minutes. So within 5 minutes, your whole flow needs to be executed. The other thing is in standard, there are no, the number of state transitions is limited. It's about 4,000 per second. And in the express, it's basically unlimited. The state transition means the flow goes from one step to the other. So this is one state transition. This is another one. Talking about the pricing, here also pay-per-use model applies. However, there's a bit of difference of pricing model in standard versus express flow. Standard basically charge per state transition, but in express it charged for the number of executions and its duration as well as the memory consumption. So it's a bit different how these two workflows work. The other service that I use is SQS, one of the oldest service in AWS. And what it basically does is it receives, save, and send messages to different components of your application or to different systems. And it's really scalable and a reliable service. There are two main types of queues, standard and FIFO queues. And standard standard type of queues offers unlimited throughput, and but it does not guarantee the message ordering. And also it only guarantees only it guarantees at least one delivery, which means a same message can be processed by the workers several times. So it doesn't guarantee that one. So you have to manage your application code according to that criteria. On the other hand, FIFO queues guarantees the message ordering, and it guarantees the one-time processing as well. So it won't process several times. However, the disadvantage is it has very low throughput comparing to the standard queues. Like it's like 300 messages per second, so which is not a big amount for a large system. Talking about the pricing, it's again pay-per-use model. So there's no upfront charges. You only pay for the usage of the number of API requests that in SQS. So the other service I use is the AWS SAM. SAM is an open source framework offered by AWS, and there are two main parts of SAM. One is SAM Transform. The other one is SAM CLI. SAM Transform is a CloudFormation extension. It provides some shorthand syntax for some commonly used AWS services, AWS serverless resources, basically. And in compile time, it converts those shorthand syntax to the original CloudFormation code. Good thing about this one is that you can include the CloudFormation code inside SAM templates as well. The other one is the SAM CLI. This is something you install in your local machine, and it facilitates build, test, and debug locally. And also you can deploy the code to cloud using SAM CLI. However, local testing is okay to some extent, but it's not really a recommended way, because most of the issues comes in integrating with different services, and especially with the IAM permissions. So it's advised to test in the cloud as soon as possible. But the problem, problem of this one is that you have to wait several minutes to get your code updated in the cloud. So if you are doing some testing or it's in the development phase, it's a bit hard. However, recently AWS SAM team has introduced a new feature called SAM Accelerate, where it speeds up the development, especially in the testing phase. How that works is it separates the actual code versus the dependencies. So normally the dependencies won't change much, and if those two parties have changes, then those will be individually deployed. So it's great experience, so that the cloud will be updated very quickly, and it's a significant improvement in SAM CLI. Personally, I like SAM because it's more towards cloud formation. Okay, let's discuss the architecture. So here, first, the webhook is created. How it works is a company ID needs to be provided along with the webhook URL. And with that API within this Lambda function, it first generate a random token, which will be used to authenticate the webhook call in the third-party application here. And those data will be saved into the DynamoDB table. I forgot to mention that I use DynamoDB single table design, where all the entities are in a single table. And once it's saved into the DynamoDB table, the token will be sent as a response. And the next part is create candidate flow. So for that particular company ID, we can create a candidate. Those data again will be added to the same DynamoDB table. Here, as I said, a DynamoDB streams enabled. So this particular Lambda function will be triggered based on the type of the type of the record created in this table, as well as if it's an insert, delete, or update event. So here I use the insert event, as well as the type is candidate. Then this Lambda function is triggered. What this Lambda function does is basically it send a message to event bus. So this is the this is the one actually transform the or form the message to be sent to the event bus. So event bus, there's a rule that triggers this step function, or the set the target as the step function, which says, okay, when a message comes as a candidate is created event, then this step function needs to be executed. So within step function, there are integrations to the DynamoDB table, Lambda, SQS, etc., to send out the webhook. It's detailed in here. So here first to the step functions, first it receives the candidate ID as well as the company ID. And there's a DynamoDB direct integration within the step function, which checks the webhook to check basically if this particular company ID has a webhook, and it validates if the data is there. If not, it skips. And if the webhook is already available, I do some transformation here. Within the step function, it is possible to transform data using input path, result path, etc. And next step is to fetch resource data. This resource data means the candidate data, because we only pass the candidate IDs. So this Lambda function will fetch the data from DynamoDB, and then again checks if the data exists. If not, it close this flow as a failed state. If the data already exists, here I create a webhook call using the Lambda integration. This within this Lambda function, what it basically does is I create a token to validate against the hash that we created when we register the Lambda function, when we register the webhook. And those data will be saved to the DynamoDB with the webhook call status as pending. And this data will be sent to a SQS queue. And within SQS, I have a webhook function attached to that, so that this will process all the messages here. And within this webhook called a webhook function, I use the method called wait for callback of the step function. So where what it basically does is whenever it fails or success, it will send the signal to step function whether it's success or fail. Like this. So there's a methods called send task success or send task failure within step function SDK. We can use that data. If we receive a send task success, then it will directly go to the update webhook call step, where it updates the DynamoDB table with the results, with success result. And if the webhook failed, I do some transformation for the error message, because two of these results are not in the same format. So I have to do some transform there. Again, it goes to the step update webhook call, where it state the webhook failed, basically. So this is one execution. I have a demo created to showcase this project. So maybe you can also try yourself following this URL. So this is basically front end that integrates three of these API gateway APIs. So first we'll create a webhook for this company. And the event is candidate created. For the moment, I only consider this event. And let me add a URL. Okay, so the sign-in token is created. This can be used in the webhook end to verify the incoming request. And let's add a user to this particular company. Once the user is created, we can check the webhook history. So at the moment, you can see this is status pending. So this is where the data is already added to the SQS, but it's not yet processed. And if we refresh it again, you can see the status change to success with the payload. I'm not sure this is clear. Yeah, with the payload, and this is the token I use. This is actually generated using the trigger at time as well as this resource ID. I use SHA-256 to hash these two values using the token that's created here. And based on this token, you can verify if this particular webhook is legitimate. So this is a success scenario. What happens if this is a fail scenario? So I will add this webhook here. So this particular URL doesn't accept any post request. So ideally, if I create a candidate for this company, it should fail. As you see, it's in the pending state, but this will not immediately fail because I have added the retry mechanism. So if we go to the step functions state machine, you see there's a one execution running. So if we go here, you can see that the data is already queued. But the result is not there. The reason is within the worker lambda function, once the error message or the the task is set as error, I have set a retry mechanism here. So it will retry twice. If you can see here, so you might see, okay, yes, task failed items. Yeah. So it will basically retry twice, and then only it will basically set this whole flow as failed, right? So it will take about few minutes. And good thing is within the retry mechanism, you can set the wait time. Like every retry, you can set, okay, let's wait for 2-3 minutes, etc. So you can set everything within this state machine. I'll give you a quick introduction to the workflow tree as well. This is the one that I mentioned. So here you have these all the actions. You can drag and drop here, and if you go to one of these step, you can configure everything here. So it's very convenient. And finally, you can export it as a graph or the definition file. Let's see if okay, this is still running. I think I have set like 1 minute interval as well, so it will take about 3 minutes to fully set this as failed. Going back to the slides. Okay, there are some design decisions or limitations I would like to discuss. It's always better to use native integrations instead of Lambda function within step functions. So here I use the DynamoDB native integration, and here the SQS. However, I had to use Lambda for some of the instances. The advantage of native integration is you don't have to basically maintain that one. But if we use the Lambda to communicate with the other services, at some point you might need to upgrade your code. Maybe the SDK is outdated, etc. So you have to manage those Lambda functions. Here I had to use Lambda function mainly because of a limitation of a DynamoDB integration. Because when we read the data from DynamoDB, it includes the how do you call the data type as well. So N for number, S for string, etc. So you can, if you don't know the exact data type that's coming from the DynamoDB table, it's very hard to map those values. So I had to use Lambda function for that one. So yeah, again, I use the retry functionality as I explained here. So it's a good way to mitigate error, or at least retry. However, that can be done in the Lambda as well. But here I decided to do it on the step function instead of the Lambda worker function, this one. So this Lambda function doesn't have any retry configurations. It will just fail even if it's the first time. Next one is I have used the standard workflows here, mainly because the wait for callback functionality from this Lambda function, because it's not supported by the Express workflows. And also this flow might take more than 5 minutes if we consider about the retries, etc. So it's the standard workflow is the best choice here. Yeah, so I have created a blog post including all these details here. Please have a look. Also, I have the GitHub repository created with all the code. So you can deploy this stack into your own AWS account using SAM CLI. And the deployment data instructions also included in this blog post. Yeah, and then that's the end of the session, and thank you very much. You can always connect with me in this social media as well as these blog platforms. You can read my other projects articles as well. And I would like you to rate this session as well, so I can improve as well. So please, it will take about just 1 or 2 minutes to rate. Here comes the most expected segment, the question. So you can win €50 AWS credit, $50, I guess. So question is, what is the name of the AWS SAM CLI feature released recently to deploy local changes faster into cloud in the testing phase? I mentioned that in my talk about this new feature. Yeah, whoever answers first will get the $50 credit.
I think there's an answer in the chat.
Let me check. Oh yeah, that's correct. Yeah, so it's a SAM Accelerate.
Okay, I think Sridhar has answered the question correctly.
Yeah. So yeah, if anyone have any questions regarding this.
Actually, Sridhar had another question where he's asked, would it be possible for step function to send an email for job status, either pass or fail? So
send an email for job status. So what can we do is okay, in this one. So let's say now once this is failed, I updated the DynamoDB integration here. But what you can do is you can add, for example, SNS here. So once it's failed, SNS message will be send email to the given list. For example, so with SNS you don't limited. It is not limited to email, but any other mechanism to send a notification. That's possible. Or even you can also with the SDK integration, you can add the SES as well, simple email service, so that you can easily send an email about that one as well. Any other question? I'll send this slide after the presentation, so
sure,
yeah, you can visit those links. Cool.
If anyone else has a question, guys, you can either unmute and ask or just put it in the chat. So Pubudu, I have a question. Like now the architecture you just showed, like if we are to deploy this to production or something, like if we are to deploy this to production tomorrow, do you think it's production ready, or is there any other changes we can do here?
Cool, that's a good question. So this is actually I created as a POC.
Yeah.
However, yeah, of course, we need some other mechanism or the improvements to make it production ready. For example, here, I have set up basic error handling here. So this can be improved as well. And apart from that, if you see this event bus is created within the stack. So it's part of this stack, right? But if you think about the production system, this event bus can be a separate system. So this is kind of a shared event bus among the organization or among all the components of your application. So those things can be improved before going to production. Also, this retry mechanism. So at the moment, I have configured the wait time for about I think 1 or 2 minutes between the retries, but those can be can be based on your business logic, but it should be more there should be more duration between those retries as well, because once it's failed, we might need to fail for the third-party application to be up and running. So there are, of course, a lot of improvements needs to make it production ready, but the basic concept is the same.
Right. Thank you, bro. And another thing, like you mentioned, you use step functions, right? And so the last time I used it, I wrote the entire definition in like YAML and then only did it. So did you also, did you entirely do it in the Workflow Studio, or did you write certain things in YAML? Okay.
Actually, I did some modifications afterwards, but the main structure is created in the Workflow Studio because it's super easy. For example, as I said, let's say I need to add the SNS publish method here. So after DynamoDB is updated, then it's very easy. And with the input path, you can filter the data actually coming from this step to this one, and also output. It's quite easy to configure everything here. And what you can do is just export it to the definition language to JSON or YAML from here.
That's great.
Yeah, it's easy.
Hi, Pubudu. It's Manoj here.
Hi, Manoj. Yeah.
Pubudu, a small question. You used, I think you have good experience in using SAM CLI, right?
Yeah.
Now, in our project, we quite used to use serverless framework for a long time. We started at the beginning. We started using SAM CLI, but we felt like by that time serverless framework had so many things, even local development and all that. What are your thoughts about SAM CLI at the moment? Like, the improvements and the things that they have done. Do you recommend using that for, let's say, over serverless framework, or what do you see using it for production development?
Yeah, actually, one of the main limitation I see in the SAM CLI is that since it's an extension for CloudFormation, the only features that CloudFormation supports is available in SAM as well. So it's a kind of limitation, because if I compare it with the framework like serverless, it has a lot of features comparing to SAM. It supports a lot of services because it's a community-driven framework. But in terms of user or the developer experience, I find those are the same basically. So it's just the personal preference. Other than that, I don't see any how do you call, I don't see any strong recommendation to use one over the other.
Yeah. Thanks, Pubudu.
Okay, if anyone else has a question, they can ask.
Yeah, also, yeah, if you have any further questions after you check in these blog posts, etc., you can always contact me in these methods.
I guess that's it. Pubudu, just
Yeah.
one last thing, like, do you have any other future plans with this architecture? Like maybe any improvements that you think others can work on now?
Yeah, I mean, with the AWS Serverless especially, everything evolves very
Yeah.
quickly. So we never know what will be released. Like quietly. So it's not just create once and stay forever, but it can be updated time to time. So we can add new features and improve the existing architectures, etc. So yeah, that's the nature of serverless basically. So I might improve this with the new features in future.
Sure. Okay, I think then we can wrap up. Thank you so much for the session. I think we all learned a lot today, and thank you everyone so much for joining. I'm sorry if you guys got disappointed if you couldn't win the credits, but we have more, so please do join us in the next session, and we will have a meetup every month for this year. So I hope to see everyone in the following meetups as well. And if you want to talk or if you want to conduct any sessions in these meetups, also do reach out to us in Facebook or in any of our social media platforms, and we will make sure to give you guys a slot as well. Other than that, yeah, thank you so much for joining. Have a great year ahead, and have a nice day. And thank you so much, Pubudu, again for your time. And yeah, I hope we could maybe do another session in the future as well. Yeah. Thank you.
Really. Thanks a lot, guys.
Thank you.
Bye.
Thank you, guys. Right. See you.